Okay, good evening everybody. We're going to move on with 8.2 of exponent properties, and this time they're involving quotients. Again, this is the same thing we were doing earlier in the year, so hopefully it comes back to you relatively quickly. Okay, I'm going to go ahead and show how you would write this. If you wanted to write this in expanded form, it would be 7 times 7 times 7 times 7 times 7. There are 5 7s there. And then on the bottom we would have 7 times 7 times 7. And so our next step, of course, we would see if we can find any ones or simplify anything out. And I see that these right here create a 1, those right there create a 1, and those right there create a 1. So then what I'm left with is 7 times 7, which is 49. Okay, so no big deal there. Now I'm going to show what we would do if we were going to use the property that goes along with dividing the same bases. So again, I should mention it real quick. The file type on this one is dividing the same base. And then the technique then is subtract exponents. Okay, so the file type is dividing the same base, and so we subtract the exponents. And I didn't do that in the first one, I did the expanded form. But if I were going to do it, it would be, so if I had 7 to the 5th over 7 cubed, that would be 7 to the 5 minus 3, which is equal to 7 squared, and we know that 7 squared is equal to 49. So it gives me the same answer as I got right there. Okay, take a look at the next one here. Again, expanded form. Notice that on this one I used the notation x cannot be equal to 0, and hopefully we are starting to understand that we can't divide by 0. So if I put a 0 in for x, that would mean a number divided by 0, which doesn't make sense. In fact, you'd have 0 divided by 0, and anything divided by itself would equals 1. But of course, that doesn't make sense. We can't have 0 over 0 equal to 1. So that would be an undefined fraction, so we can't do that. So it's just a quick little notation there. So on this one, if I were to write it out, it's going to be x times x, 3, 4, 5, 6, 7, 8, 9. And then on the bottom of that one, it would be 1, 2, 3, 4. And of course, I'm going to simplify these again. Those simplify out, those simplify out. And remember, I'm finding ones here. I'm drawing giant ones. They're not crossing out. They're not becoming 0. They're becoming a 1, because anything over itself is 1. And so then my answer to this one would be x to the 5th. Now if we use the property, that would be x to the 9th over x to the 4th, which is equal to x to the 9 minus 4, which is equal to x to the 5th. Okay, so we see that we in fact do get the same solution both ways we do it. And the last one that we're going to look at down here is what if we have a fraction multiplied by a whole number. So on this one, what I would want you to do is I would want to simplify first. We've been talking about that quite a bit. Simplifying first. So I'm looking for things that I can simplify, numerators with denominators. So I see that I have the same base right here and here, which means I can simplify these two. So I don't have to have them directly above each other. If it's multiplication, I can simplify a cross like that. So I'm going to have, is going to be y to the 9 minus 3, which is y to the 6th. And then my denominator is over 1. So that would be equal to y to the 6th. Now, I'm going to show it the other way, which most of you would probably be more comfortable doing, which would be to multiply 1 times y to the 9th, and that would give me y to the 9th over, and then y to the 3rd over 1, which is y to the 3rd, and then I would have y to the 9 minus 6, which is equal, oh, excuse me, no I don't. I have 9 minus 3, getting ahead of myself. And of course, then that would be a 3 there, and that would be y to the 6th. So again, get the same answer. either way we do it. So, all right, so there's the lesson, that part of the lesson. Now let's take a look at the next slide. And I got similar things, like this time I have fractions involved. So what I want you to do on this one is to, the safest thing to do on this one is to put in a 1 here and a 1 here. And then this, would, of course, would be raising a power to a power. So then this would be equal to 3 to the third over 4 to the third. Okay, 3 to the third, 4 to the third, and there's nothing we can do. I'm not going to ask you guys to multiply those out. That's fine right there. The next one here, it's again raising a power to a power, but we have division involved. So the key thing is you got to make sure you put a 1 on your denominator as well. Everybody wants to square the x, or excuse me, raise the x squared to the fourth, and they forget the y to the first. Everything inside is being raised to that power. So then this would be x to the 8th over y to the 4th. Okay, it's a very important one right there. Make sure you're doing that one correctly. And then we have this one down here. Quite a bit of stuff going on, so we want to do the file type first. And the first file type that we would use on this one is power to a power. Okay, so I want to do this right here first, power to a power. Get rid of those parentheses. I hate having parentheses. Okay, so power to a power is going to give me x to the 4th over y to the 10th, now times y to the 7th. And just like we did on the previous slide, we can now simplify this. So I get over 1. So I'll do it the way you're probably most comfortable, which is fine with me. X to the 4th, y to the 7th over y to the 10th. So this is equal to x to the 4th times y to the, sorry. Okay, sorry, I did not mean to do a negative exponent quite yet. So I'm going to go back and change this way over here. I'm sorry about this. I didn't catch that I was doing a negative. This right here, I'm going to leave blank. Leave blank. So then this is going to be incorrect. And this. Sorry about that. I know you guys do your stuff in ink. My bad on that. We're going to leave it blank. So then the first thing that we would have done then is we would have put in a 1 right there. Whoa, that's a huge 1. Okay. Alright, try this again here. So then the first thing we're doing is put a 1 right here. And so then that would have given me y squared. And then now that's y squared right there. So then this is the 7 minus 2, which would give me x to the 4th, y to the 5th for my final answer. Okay, so that's that. Okay, now the next slide is a little bit different. So on this slide, I saw some issues today in class, and I don't think you guys were paying close attention to the details of the work, so I'm going to have to point it out to you. And what I want you to do is on the next 2 slides, I got this slide and one more, I want you to look at these 2 questions that I have here, and then I want you to post your answers in the comments section of the reflection. So I want you to tell me what you think. So the first question is, does 5 squared equal the quantity 5 squared? Okay, so does this right here equal this over here? And you're just going to tell me yes or no and tell me why you think what you think. And the second question I have in, based on what you think up here, then does this negative 5 squared equal the quantity negative 5 squared? And then again, why? So you're going to post this in the comments section of your of the reflection, please. All right, and the next slide shows the last question. And the last question here is same thing. You're going to post your answers to the reflection section of the to the comments section of the reflection. And the question then is this: does this right here equal this right here? And then the second question is, does this equal this right here? Okay, so those are my two questions that I have for you to post onto the reflection section of my, or the comment section of my reflection. Okay, I'll see you guys tomorrow.